Okay, so ladies and gentlemen, what we're going to do is we're going to work on graphing the sine function. All right. Now to graph the sine functions, we need to kind of understand, well, how do we even graph, just regular functions or anything else we need? So before I even get into this point, I want to go through at least, let's go back actually to graphing equations. If I just gave you guys the equation, y equals 3x plus 2, right? When we're graphing a linear equation like this, the first way you learned how to graph, before you even went into what is slope-intercept form or any other forms, the first thing we learned how to graph was by using a table, correct? We found a table of values. And the table of values, remember, we just say, all right, to find a table of values, we're going to choose x coordinates and choose y coordinates. And this is what we said was the input. And here would be the output, all right? And this was true for all different functions. Right now, I'm just going to talk about an equation just to make sure, because we're going to use an x and y axis. So in this case, what we would do is we just picked values for x, right? We found values for x. We inputted them into the equation. And then we found the output, correct? So in this case, you could say that this was 1, you could say 2, you could say 5, and you could say 8, right? Then once we learned about how to graph equations, so then when we were going to graph this, we'd graph it looking like this. We'd graph it on the x-axis and the y-axis, right? But then we started looking into and then we started talking about functions. And functions was the exact same thing, but now functions had to follow a certain part of rules, right? Where your input, when you plugged in an input, there could only be one exactly unique output for that input. So we call them functions. But everything remained the same. The process and everything else we did, except for instead of calling it the output y, we called it f of x, or any other name for a function. And therefore, a graph was f of x. But the main important thing I want you guys to understand is you have an input and you have an output, right? OK. So what we're going to work on doing is graphing the sine function. And what I want to do is at least give you guys an idea of where does the sine of x graph come from. What does it look like, and why does it look like how it does? All right? So the exact same thing. We need to plug in. If we have this, we can create a table, right? We take our input values, which is x, and then we found the output. So what I did was I created a whole bunch of inputs. Right? You guys can see if I was going to set a table, okay, I did a whole bunch of x, f of x. I'm not going to rewrite them down, but you could say my inputs now are pi halves, pi, 3 pi over 2. Right? You guys can see how I just kept on labeling and labeling all these. So now what I want to do, actually I'll label all these. Now what I want to do is determine what are the output values for the sine function. 5 pi over 2, 3 pi, 7 pi halves, and 8 pi. OK, so those are all my input values. Now, how are we going to find the output values? Well, the nice thing about each one of these angles is they cross at a point on the unit circle that we are familiar with. So if we go back to the unit circle real quick, lovely unit circle. We know that when we talked about the unit circle, there was 4 major points that were the easiest to remember, right? Because remember, this unit circle has a radius of 0. Sorry, 0, -1. OK? Now, I know the interior points are a little bit more difficult, right? Because those you have to kind of remember from special triangles. But from right here, these are very easy points to kind of go through. And now we just need to go through, well, what is exactly all the angles? Well, remember, halfway around a circle, that would be pi. So when we're looking for what is the sine of pi, well, we know that, remember, sine represents the y coordinate when you have the point on the unit circle, right? So we could say sine of pi is 0. Then, if that was sine of pi, then this would be sine of pi halves. So sine of pi halves is 1. And then let's just start at 0. Let's pretend we didn't move anywhere. Sine of 0 is 0. All right? Now, what I'm going to do is I'm going to count in terms of pi halves. All right? So if we go here, that's pi halves. that's 2 pi halves. 2 pi halves is the same thing as pi, right? So therefore, that's 3 pi halves. So that's negative 1. 3 pi halves. This is 4 pi halves. So if I go all the way around the circle, that's 4 pi halves, which is the same thing as 2 pi. So 4 pi halves, again, goes back to 0. Then we continue around. So that's 4 pi halves. This would be 5 pi halves, which is, again, is 1. Continue around, 6 pi halves, which is the same thing as 3 pi, which, again, goes back to 0. 7 pi halves is, again, back to negative 1. And going back to 8 pi halves, which is 0. Now, ladies and gentlemen, if I keep on continuing going around, Kyle, do you see any reason why these points are anything going to be different? If I just keep on going around the circle, am I going to get any other different values? No, right? This keeps on continuing over and over. It's a cycle over and over and over. All right? That's tangent. It's a pretty function.
Like tan
Tan
lines?
lines? OK, so what I'd like to do now is, so now, ladies and gentlemen, we have a graph. Or we have points that we can create on our graph. 1. What did I miss? Did I miss a value? Oh, I didn't do 0. 0, pi. What did I? Yeah. Pi is 0. 3 halves is negative 1. 2 pi is 0. 5 pi halves is 1. 3 pi is 0. Negative 1 and 0. OK. So what I'm going to do, ladies and gentlemen, is now I'm going to create a graph. So let's go and take a look at this graph. All right. So remember, just like anything else, guys, a graph has an x and a y axis. But in this case, we don't have an x and y axis. We have an x-axis and an f of x axis. Or better noted as an input and an output, right? So what were our inputs? 0, pi halves, pi, 3 pi halves, 2 pi, 5 pi halves, 3 pi halves. And you guys notice that each of these were pi halves away from each other, right? The distance, when I wrapped around the circle, they each were pi halves away from each other. So they're evenly divided, or evenly separated between each other. So what I'll do is I'll just create some coordinates, or some spacing. And I'll say that this would be, obviously that's at 0. So this would be pi halves, pi, 3 pi halves, 2 pi, 5 pi halves, 3 pi, 7 pi halves, and this would be 8 pi. All right, now, I only did the positive direction for you, but can we also go in the negative direction? Mm-hmm. Yeah, so what about it look like? This would be negative pi halves, pi, 3 pi halves, and let's just go to 2 pi. OK? So that's our input. Those are the values that we chose in our input. Remember, those represent the angles. Now, the output, though, is not in those same kind of terms, right? Our output, what were our numbers in output? 1, 0, and negative 1, right? It didn't go anywhere higher than 1 or negative 1. And we'll talk more about that in a second. So when I'm graphing, when I'm setting my scale for the output, I'll just go to 1 and 2, just so, because we'll talk about that. All right? So now, ladies and gentlemen, what I'm going to do is show you just how to graph. All right? So same thing. Just make coordinate points. At sine of 0, we have 0. Sine of pi halves is 1. Sine of pi goes back to 0. Sine of 3 pi over 2 is negative 1. Dot, 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 dot. OK? So when I connect my points, I'm not saying any assumptions, but here's the points we plotted, right? When we put them on an x and y axis, this is what we get. Now, if I go in the negative direction, do you think it's just going to continue this exact same pattern? Yeah, exactly. So negative pi halves is negative 1. Negative pi is 0. Negative 3 pi halves is 1. And negative 2 pi looks like that. OK? So if you guys go ahead and graph in your calculator, sine function, this is exactly what you're going to get. The important thing I want you guys to understand is your x-axis is not broken up into numbers at this point in time. We're going to talk about when we can do that. But I want you guys to understand the input values are different than the output values as far as our scaling. Okay? And there's nothing wrong with that. Right? When you guys were learning a graph, sometimes you guys, remember when you guys learned a graph, you could say, I'll have the x-axis go by 10s and the y-axis go by 5s. Right? To make the graph fit on a scale, sometimes that's what you had to do. Well, ladies and gentlemen, we have our input values are in terms of pi for this problem. So that's how we're going to scale it. All right? So, ladies and gentlemen, that is the introduction of the sine function. Just do x.